Welcome back to the 60-day pentesting challenge. Yesterday we covered Burp suite fundamentals, setting up the proxy, intercepting requests, reading HTTP traffic. Today is where it gets interesting. We are going through repeater, intruder, sequencer, comparer, and decoder. These are the tools that turn Burp from a traffic viewer into a vulnerability discovery platform. If you are following along, open Burp and a test target like DVWA or Juice Shop. Let us start with repeater because this is where you will spend most of your time. The concept is simple. You take any request from your proxy history, right-click, send to repeater. Now you have the full request on the left, and when you click send, the response appears on the right. You can edit anything, headers, body, URL path, method, and resend instantly. No need to rebrowse the application. Here is a concrete example. Say you captured a request to view your profile at /API/users/1005/profile. In repeater, change that 1005 to 1006. Hit send. If you get back user 1006's profile data using your own session token, that is an insecure direct object reference vulnerability. You just found a real bug in under 10 seconds. Now try 1007, 1008. But doing this manually is tedious, which is exactly why Intruder exists. Intruder automates sending many variations of a request. You define positions, the parts that change, and payload lists, the values to insert. But there are 4 attack types, and picking the right one matters. Sniper takes one payload list and tests each position independently. If you have 3 injection points and 100 payloads, Sniper sends 300 requests, 100 for each position, one at a time. Use this when you want to test each parameter in isolation, like checking which fields on a form are vulnerable to cross-site scripting. Battering Ram puts the same payload into every position simultaneously. 100 payloads means 100 requests. Use this when the same value needs to match across multiple locations, like a CSRF token that appears in both a cookie and a hidden form field. Pitchfork uses multiple lists in parallel. List 1 feeds position 1, list 2 feeds position 2, stepping through them together, 3 to 4 o'clock. Sequencer is the tool nobody talks about, but it has saved me on multiple engagements. It answers one question: are these tokens actually random? Right-click a response that contains a set cookie header, send to Sequencer, and start a live capture. Sequencer replays the request thousands of times and collects each token it receives. After 5 to 10,000 samples, click Analyze. Sequencer runs statistical randomness tests and reports the effective entropy in bits. Framework default session IDs from PHP, Django, or Spring typically score above 100 bits. That is fine. But custom token implementations are where problems hide. I tested an application that generated tokens by base 64, encoding a timestamp concatenated with the user ID and a static padding string. Sequencer scored it at roughly 18 bits of effective entropy. The timestamp was predictable to within 1 second, the user ID was sequential, and the padding never changed. An attacker could enumerate valid session tokens in minutes. That single sequencer finding was the highest severity item in the entire report. Comparer and decoder round out the toolkit. Comparer does byte-level diffs between any 2 responses. Send 2 login responses to comparer, one with a valid username and wrong password, one with a completely invalid username. If the error messages differ by even a single character, you have username enumeration. The application is telling attackers which accounts exist. Decoder handles encoding and decoding chains. Paste a suspicious cookie value, base 64 decoded, and suddenly you are looking at a JSON web token with the user's role in plaintext. Now you know the token structure and can test for JWT manipulation in Repeater. The real power is chaining these tools together. Here is how a typical assessment flow works. You browse through Proxy and spot an interesting API call in your HTTP history. You send it to Repeater and confirm the endpoint reflects user input or uses a predictable identifier. You send it to Intruder to test at scale, maybe fuzzing that identifier across thousands of values or testing a parameter against an injection word list. You take two interesting Intruder results and send them to Comparer to pinpoint exactly what differs. And if you find encoded values anywhere in the process, Decoder breaks them apart. Proxy to Repeater to Intruder to Comparer. That chain accounts for probably 80% of my web application findings. It is systematic, repeatable, and thorough. One important note. If you are using Burp Community Edition, Intruder is throttled to roughly 1 request per second. For learning and small word lists, that is totally fine. For professional engagements where you need to test 50,000 entries, you either need Burp Pro or you can use free alternatives like Fuff or Fuzz for the high-volume fuzzing and keep Burp for everything else. Tomorrow we shift from tooling to taxonomy, the OWASP Top 10. That framework gives names to the exact vulnerability classes we have been hunting for with these Burp features. See you then.